Hey there, it's Matt Williams, your favorite evangelist. For work, I use Kubernetes quite a bit, and I'm often pulling data out of the JSON blobs that come out of kubectl. There are ways to extract portions of those JSON blobs built into the kubectl command, but I never really remember how to use those features. And I'd rather get really good at one tool that I can use in lots of places than learn a one-off. So I like to use JQ for the same thing. The only little problem is that I never remember the syntax for that either. Well, it seems that I am not alone because Adam Gordon Bell, who's a dev advocate at Earthly, wrote a blog post to help him remember everything that JQ can do. Now, I haven't played with Earthly yet, but it says it's a syntax for defining the build in your CI system. I need to dig into it, but I'll do that another time. Let's use our time together today to talk about JQ. JQ's page says it's like sed and awk and grep for JSON data. That's an accurate description in lots of ways because just like those tools, it's super powerful and I can't remember the syntax for any of them. But I'm going to assume that you know what JQ is and you may even have it installed. If you're on a Mac, you can install it with brew. So what's my intention with this video? Well, I'm just going to cover most of what Adam covers in his article, but I'm going to apply it to Kubernetes. Now, let's say I want to get information about one of the pods in my Kubernetes cluster. Now, I'm an evangelist at Datadog, so I'll use the Datadog agent as my example. I'll run kubectl get pods to get all of my pods. Here you can see all my pods in the default namespace. There are a bunch that are Datadog related, so run that with a label to see just the agents. But there's still 3. This is because I have a master and 2 workers without any taints on my Datadog deployment. Let's run it with the wide output, and we can see where they're running. Let's get the JSON for one of the workers, and we'll specify the worker pod and say output is JSON. It's all there, but it's a bit hard to find things. Pipe it to JQ, and it's suddenly prettier. For many folks, this is as far as they go. But filter expressions are where the magic really starts. Filter expressions follow the JQ command in quotes. If I set the filter to .metadata, I see just the metadata block. Add .name to the end of the filter and I get just the name of my pod. Great. Now I always find it a bit annoying that when the output's a single string, it's wrapped in quotes. So you can add the raw option, or -r, to get rid of those quotes. The Datadog pod actually includes a number of containers, and in the output JSON, it's represented by an array under spec.containers. If I run the getPod command with that filter, I get an array of all my containers. How many containers? Something you're going to have to figure out, right? Well, it turns out there are some special functions in JQ, like length, to show the number of items in an array. But you can't just tack it on to the end of the filter like this. You need to use pipes. So pipes in JQ behave just like they do in your shell. The output of the previous command, or in this case a filter, is piped to the next command, or filter. But all the filters are enclosed within your one set of quotes. So if you use a filter of .spec.containers pipe length, you'll see the number of containers in our pod. What other functions are there? Well, go to this page in the JQ manual, and you'll see that there's a lot of functions. Sort to string, min, max, unique, contains, inside, starts with, join, split. There's so many. It's super cool to see what you can do all inside of JQ. If you want to see just the JSON for the first container in the array, you're going to have a filter of .spec.containers and an index of 0. Just like in a lot of programming languages, it's a 0-based array. If we had 5 items, they'd have index values of 0, 1, 2, 3, and 4. Let's say I want to see which environment variables are set for the first container. Just tack on env to the end of our filter. And if I want the count of environment variables, pipe that to length. But you knew that already, right? What if you want the count of environment variables for each of the containers? Just remove the index from the array, but not the square bracket, and there you see a list of counts. But maybe you want the total count of environment variables across all containers. We'll just pipe that to add. Well, you can see that that doesn't actually work. You can either provide all the arguments to add, or it can work on an array. But our list of results isn't an array. To convert it into an array, we wrap the filter in square brackets, and now you can pass that to add. Let's look at the environment variables again from all the containers. And that's a filter of .spec, and then the array containers, and then the array env, and then name. You can see that a bunch of them are repeated. So let's get that list again and then wrap that in square brackets to create an array. Now pipe that to unique and we get a subset of names. Pipe that to length and we get the total number of unique environment variables. Wrapping the filters in square brackets is a really neat thing to do and opens up your results to a lot of possibilities. And knowing that you can pipe the array to a function that does more means JQ just got a whole lot more powerful. Now what if you want to get multiple fields out of the JSON? Just separate the filters with a comma. Let's say we need the name and image of all our containers. We can add the full filter for the name, add a comma, and then the full filter for the image. But that results in a list of names and then a list of images. If we had a lot of each, it'd be hard to read, and a lot of typing to get the filter right. And if there's an error, you have to fix it in a few places. So let's get to the right block in the filter, then pipe that to .name, comma, .image. Now we see the names and images together, and it's easier to update. And just like we did with arrays, we can wrap the filter in curly braces along with some names and get a new object. Let's go back to our environment variables. Let's say that you want a list of environment variables with a particular value. Let's start by getting all the environment variables. Wrap that in square brackets to get an array. Now we can pass that to the map function and do some exercise on each item in the array. Let's say that you want a list of all the environment variables across all the containers that include the word true in the value. We can use map select, which is kind of like filter in other languages, and say if .value is true. That gets us a list of objects, but we know that all the values are true, so filter that to just include the name, and there we are. All the names in our list are in quotes, so we can add -r to get rid of those quotes. Maybe looking for true isn't all that valuable, but figuring out if one environment variable refers to a specific path, well, that is pretty useful. So there are a number of other examples in the doc, so it's well worth the read. Adam also points to some other resources to get you up to speed on JQ. Then find some JSON that you need to work with and figure out how to take advantage of that. JQ is super cool, and if you find yourself using JSON at the command line, it's an amazing tool to keep in your tool belt. It's always in mind, and hopefully now I won't have to constantly refer to TLDR or other similar commands to get me through the basics. My name is Matt Williams, and I'm an evangelist at a cool software company. I hope you found this video interesting, and watch out for the next one, where I am sure I'm going to talk about something else that I am super excited about. I just don't know what it is yet. Bye.